In this video, we'll talk a little bit about a topic generally called motivated reasoning, the tendency for us to process information differently depending on if we like it or not. In a nutshell, basically what motivated reasoning is about is the idea that emotions distort our perception of facts. This is very different from misinformation, which is about things that are not factually accurate. We'll get back to that later. This is also sometimes referred to as confirmation bias, or the tendency for people to selectively prefer information that confirms their prior beliefs. In a sense, this view challenges some of the core propositions from some cognitive psychologists that our minds are like computers. Perhaps a better analogy, rather than the computer, would be to think of human minds as like a lawyer. Because what does a lawyer do? A lawyer presents facts and evidence selectively in order to support a predetermined goal. And that is often how human minds work in everyday situations. Some studies use what's called a false feedback paradigm. This is when participants in studies are randomly assigned to be told things that are favorable or unfavorable about themselves. So participants might take a brief quiz or a survey, and then they're given feedback that they're either very, very intelligent and popular and very healthy physically, or they're told that they're very unhealthy and very unintelligent, and their personality kind of, they're kind of lame. So what happens when people get this feedback, which, by the way, is totally random and has no bearing on their actual personality or their actual health? But when people receive feedback that they like, when they're told positive things, then we tend to accept those things without question. We say, oh, well, this is wonderful. Of course, I'm smart and popular and healthy, and we go about our day. But if people are given the negative information, that's when motivated reasoning starts to kick in, and people are more likely to question the validity of the methods that were used and demand follow-up testing and then downplay the significance. As for why this happens, one idea put forth by some psychologists is that there's an ego protection mechanism, that this is all really about self-esteem. We want to feel good about ourselves, so we accept good information and we reject bad information. But other psychologists suggest that this has to do with our social identities. And when people identify with social groups, for example, political groups or nations, those groups develop moral and ethical norms and also goals for what we hope to achieve. And if we feel that facts we come into contact with will threaten our group's norms or goals, we may reject those facts. So this is often the case when people are presented with information that might have big societal implications. Let's look at some of these studies. And before we go into detail on the results of this specific study, I want to try another exercise with you. And again, just like with the false feedback studies, these data are not real. These are made up data. But the premise is that these are data showing the efficacy of a new treatment for skin rashes. Doctors are testing different kinds of treatments, and your task as the participant is to decide, based on these data, whether the treatment worked. So some people in the top row use the cream, that's the treatment group, and in the bottom row we have the control group, those that did not use the cream. And then for the two columns, we have the numbers of people who got better and the number of people who got worse. So, pausing the video for a second, taking a look at the numbers, what do you think? Did the treatment work? Now, this is a bit tricky. In fact, this exercise is often given to med students, and a high proportion of folks who are given this problem to solve get it wrong, in part because of what we call an anchoring effect. People are drawn heavily to the top left number, the big 223 number. And because that's the number of people who used the new treatment and got better, we tend to think that the treatment worked just based on that one piece of information alone. However, on closer inspection, we see that actually 25% of the people in the cream treatment group got worse, compared to only 16% that got worse in the control group. So the correct conclusion here is that the treatment did not work. And we get the same result if we flip it around. So the anchoring effect could be used in the opposite direction to suggest that 25% of people got better if you just flip the columns around. That's not important. The important thing to note from this experiment is that even though it's very tricky, the better people are at numerical cognitive abilities, in other words, to the degree that people are smarter, they're more likely to get this question right. So cognitive ability predicts getting the correct answer, and it doesn't matter what your social group is, because in general, social groups don't really organize themselves over things like this. Generally speaking, whether you're American or not, whether you're Democrat or Republican, whether you're liberal or conservative, doesn't really matter to you whether a skin rash treatment is effective or not. That's not something that's a salient part of our group identities. But then the researchers used the exact same experimental scenario, except they switched the issue. Now, instead of deciding whether a skin rash treatment worked or not, it's whether gun control measures or policies worked or not. Notice how the numbers here are exactly the same. And again, we have this kind of anchoring effect with the top left 223 number. But this time, participants have to decide, did cities that ban guns experience a decrease in crime or an increase in crime relative to cities that did not ban guns? In other words, the question is, do gun control policies work across major cities? Now here we get a much different result than for the previous iteration of this experiment. Remember, I told you a minute ago that in the skin rash treatment experiment, the smarter people were, the more likely they were to get the correct answer. But that was not the case in this version of the study. In this version, what we see is evidence of political polarization. Liberals, or Democrats, here looking at the data for the blue lines, we see that they were more likely to get the correct answer if they were smarter, but only if it was consistent with prior beliefs that crime would decrease as a function of gun control. If the evidence showed the opposite, it didn't matter how smart people were. They were no more likely to get the correct answer. And the inverse was true for conservative Republicans. The smarter they were, the more likely they were to get the answer correct, only if the data showed that crime increased as a result of gun control. If the evidence showed that crime decreased, it didn't matter how smart they were not more likely to get the correct answer. Some researchers and journalists suggest that this means that politics makes us stupid, that our brains stop working essentially and we're not able to reason correctly about things like numbers and what they tell us. But I would suggest that the real explanation here is about our social identities and motivated reasoning. That is, people are more likely to reject true information if it conflicts with their worldviews. So just to recap what we found in this study, they found that intelligence predicted an increased likelihood of getting the correct answer for non-politicized issues like skin rash treatments, but intelligence did not predict getting the correct answer for politicized issues like gun violence. Now, is there a solution here? Is there a way we can overcome these biases and help people arrive at the correct answers regardless of their social identities? And the answer is yes. At least some evidence suggests that when people feel more curious, then they're more likely to arrive at the correct answer, regardless of which political group they're in or what their social identities are. So these data are taken from surveys that are given to people to assess to what extent they think climate change poses a threat or a risk to human health, safety, and prosperity. And on the bottom left, we see the smarter people are, in other words, how intelligent they are in terms of science, the more polarized they become. So people who are liberal Democrats and have high intelligence are more likely to think that global warming is a threat, but conservative Republicans are less likely to believe that global warming is a threat. However, on the bottom right, we see the opposite pattern of results for curiosity. The more curious people are, it doesn't matter if they're a liberal Democrat or conservative Republican, either way, they're more likely to believe that global warming is a big problem. Same question here on the next slide. Is there solid evidence that recent global warming is occurring due mostly to human activities like burning fossil fuels? Well, if you're highly intelligent, then it really depends on whether you're liberal or conservative, and we're going to get this polarization effect happening on the bottom left. But if we are highly curious, doesn't matter what your social group is, you're going to be more likely to agree that there is solid evidence of recent global warming due to human activities like burning fossil fuels. Now, importantly, because we didn't really define what scientific curiosity is here, it really doesn't have anything to do with how intelligent or knowledgeable you are. It has to do with your level of interest. And this is not measured with standardized tests or whether you got a college degree, but how much time you spend reading articles or books or watching documentaries or video clips online about the topics that interest you. The great thing about scientific curiosity is that it's something that humans are born with. And we see that scientific curiosity is also evenly distributed across the political divide. So there are just as many highly curious conservative Republicans as liberal Democrats. That's in the general population. We don't actually know if curiosity is evenly distributed across, like, members of Congress. It wouldn't surprise me if we found different results there. Overall, I think some of the research evidence here suggests that it's very difficult to change people's minds, and very often people tend to over-rely on facts rather than curiosity in order to change people's minds, but that doesn't always work. Given what we know, I'd like to pose to you a challenge. This is an opportunity for you to earn a little bit of extra credit. This is what I call the Changing Minds Challenge. I want you to see if you can change someone's mind about something that is objectively true or false. So in other words, if you know someone that has an objectively false belief, I want you to see if you can change their mind. So if your friend, for example, believes that there was a big conspiracy involving NASA and we never actually landed on the moon, I want you to see if you can change their mind. If you know someone who's a flat earther, if you can convince them that the world is indeed round, then that would count here. I don't want you to focus on opinions, though. That's different. If you have someone who's never tried sushi and you get them to try it and they like it and their opinion changes, that's fine. I don't think that that would qualify, though, for this challenge. It has to be a false belief, something that is objectively not true, and you're changing their mind. If you want to know how you can get credit for doing this, I would suggest first, actually go and try to do it, and then reach out by email and let me know how you did. Let me know a little bit more about the specifics of the belief that someone you know had and how you were able to convince them otherwise. Often I will take a testimonial from this other person, so if the other person wants to join us on a Zoom call or send me a quick email verifying everything that you've said is true, then I will accept that for the bit of extra credit. One more thing before we close this video. At the beginning, I mentioned that the ways in which we experience mental processes that are biased with regards to things like heuristics or mental shortcuts, that's different from how we consider misinformation. So if you're curious, well, what about misinformation? What about fake news? How do we reason about this? That's a whole other topic. So here's what I suggest to you. If you're curious about this, put your ideas and questions in the discussion thread for this unit, and I'll make a video based on the questions and ideas that you have about this topic and post it soon.